Good evening, everyone. Thank you for joining tonight's AeHIN Hour webinar. Please note all microphones are muted throughout the meeting, and for comments, please use the chat box, and for questions, please use the questions box. Tonight's speaker is Professor James Agnew. He is a software developer and standards geek who has been focused on healthcare interoperability for the last 15 years. He leads the Happy project, an open source project which develops free implementations of HL7 standards, and he is also the Chief Technology Officer of Smile CDR. May we now call on our speaker, Professor James.
Okay, there we go. Can you see my screen?
Yes, Professor James, thank you.
Perfect, thank you. All right, so hello everyone. I guess I'll start by saying it is very early in the morning here in Canada where I'm located, so if I sound a little sleepy, I apologize for that. But what can you do? It's 7 a.m., so I suppose it's morning here too. There we go. So this is a picture of me, as Charisse kindly said. I am a standards geek before anything else. I've spent many years sort of developing software in the healthcare field. And I find standards particularly interesting, and data flow and data exchange. I've always found all of that stuff really interesting. So that's been a big part of my life for quite some time now. I have been leading a project called Happy, which of course I'm going to talk about a fair bit during this presentation. Happy is an open source implementation of a number of HL7 standards. And I've been working with that project for quite a while. More recently, I joined a project called Smile CDR. We're a little software startup who are selling a FHIR repository, so it's very close to my heart. And I am also working some of my time for a hospital network here in Toronto, Canada, where I'm based, called University Health Network. So I will say before getting into any of the presentation that this presentation is all free content. I like to license talks under the Creative Commons license. Which means, of course, you are welcome to a copy of this. We will, of course, circulate the slides. You're welcome to these. You're welcome to give this presentation yourself if you'd like. All of the content is out there for free, and any code snippets that I happen to show are all Apache Software License 2.0. So this is all very free content. The other thing I will say by way of disclaimer, of course, is that this presentation is just a teaser on the topics that I'm going to talk about. All I mean by that is FHIR is naturally a very big topic, as is Smart on FHIR. I could probably spend the entire day talking about those, and in fact, I've done that many times. So of course, you know, in half an hour, there isn't not naturally enough time to really get into much of the real details of everything, but we'll get some teaser content out at least, so that's fun. Okay, there we go. So before talking about FHIR in general, I like to set the stage a little bit by talking about what do we mean when we say we're building interoperably HRs. So I'm going to talk a little bit about a few of the models that we use to sort of build interoperable systems that we use for connecting healthcare data to other systems. I suspect some of this isn't new information. In fact, most of this is probably not new information for everyone, but it's a good place to start. There's a few sort of models that we use for that. The first is the traditional messaging model, which is to say that we have one system which is subscribed to another system and receives events every time some sort of business process happens. The classic example of that, of course, is things like ADT messaging using HL7 version 2. ADT messaging naturally is a real simple concept. It's just something like a registration system broadcasting events to every other system in an organization when a new patient has been created or a new encounter has been started or someone has been discharged, any of the various workflow steps that you typically have within a registration system. This type of model is, of course, very popular within the realm of hospitals. Hospitals around the world, I mean, you're hard pressed to find hospitals anywhere really that don't have at least one system that's able to speak HL7 version 2. This is a very common thing. The standard, of course, doing this, as I mentioned, is HL7 v2.x, which is an entire product suite, but the messages are all quite similar. And the data that gets passed around, I've got a sample of it up on the screen. This is kind of what it looks like. And the whole idea is naturally, we're just passing data from point A to point B. The second model that we see a fair bit these days is the model of document exchange. Document is really all about sort of packaging up a set of relevant data to some sort of healthcare encounter, packaging that up into a document, and then pushing it to someone who is ready to consume it. The documents that we send, I've got a few examples up on the screen. We send things like discharge summaries, continuity of care documents, CCDs, and the whole CCDA family of clinical content, notes and letters, that type of thing. This type of workflow is probably most widely implemented in the US. It forms the basis of the health information exchange model, which is used a lot between organizations within the United States. It's an interesting model. There are not too many workflows that really sort of subscribe very well to the idea of pushing a document from one person to another. Referral is one great example of that. I think this particular model has been used quite successfully in cases where you're transferring care from one provider to another, and that transfer is happening between organizations especially. We tend to see this type of exchange be fairly popular within that type of workflow, but there's a lot of workflows where it doesn't fit terribly well. The dominant standards that we use for that for this particular type of exchange, there's a few. HL7 clinical document architecture is a data format. It's not a data exchange format, but it's a great sort of payload format. It's a great way of representing the data that we're going to send between systems to fall into this paradigm. There's a protocol called Direct, which is used in the United States. It's effectively a type of email for sending clinical documents, a secure email. A great deal of the data that's exchanged this way is done with traditional SOAP, SOAP being sort of a content-neutral XML-based transport protocol. SOAP is a really complicated and not my favorite technology, truthfully, but it is a good way of exchanging XML payloads, so it is fairly popular for that. The third model I'll talk about in terms of how we build on interoperability is the repository model. So the repository model is essentially standing up a central database that all of our systems are populating with their data and making available for other systems to consume. That sort of model, it scales well to different sort of sizes of use case, which is nice. You see repositories being stood up in the middle of a hospital with all of the clinical systems feeding their data into a repository within a hospital that might have a number of systems, but we see it all the way up at the jurisdictional level as well. States and provinces can do this. Regions of healthcare delivery can do this. Even federal sort of governments can do this type of model. It tends to sort of scale from small to big quite well. There are a number of big implementations of the repository model that we can point to. Given that I'm in Canada, I like to talk about the models here. We use this model quite extensively here in Canada. We've got provincial databases for things like who are our patients, what lab tests have they had done, what radiology reports do they have available. So we have been here in Canada hard at work at standing up great big repositories for various clinical domains of data. And then those repositories are available for anyone who is treating patients for direct patient care, as well as being made available for things like system planning and disease surveillance and that type of thing. So that's been a very successful model for us here in Canada, or at least we've had some success with it. There is a number of standards that get used to support the repository model. Certainly the dominant standard around the world, although a little bit less so here in Canada, is IHE XDS, cross-domain document sharing. So XDS, of course, is an architecture that specifies that we have an index database and a repository database, and those two work together to serve up content. XDS really focuses on metadata. So who is the document about? What type of document is it? It doesn't really get too much into what does the payload look like. We see people trying to use HL7 version 2 and HL7 version 3 as standards for the repository model. Here in Canada, we've used those two for most of that work. I would say most of the challenges we've had come back to our choice to use those two standards, but they were what was available at the time we set down that road, so there we go. The final model, and this is kind of getting at the heart of what we're talking about today, is the app model. So increasingly there sort of is growing both consumer acceptance and consumer demand for apps. Lots of people have smartphones and tablets, and lots of people are getting used to this idea that whatever workflow they have, whatever problem they have to solve in their life, there's probably an app that does exactly that thing that they can put onto their smartphone or onto their tablet. Increasingly, given that the consumer sort of technology industry is moving that way, of course, healthcare is starting to follow in that same path as well, and people are starting to recognize that it's hard to solve a number of healthcare's problems that are specific to an individual practice or user or disease with a great big monolithic software that does everything. It's much easier to solve specific problems with specific pieces of software, and apps are sort of a great example of that. So the new sort of trend, or at least one of the new trends in the world of sort of developing healthcare informatics and healthcare apps, is this idea that these little focused, purpose-built apps connected into the rest of the EHR are a part of our solution for delivering healthcare data. Naturally, the way that looks, and I've shown it on a diagram on the right, is we retain our EMRs and our EHRs. None of that goes away. None of our existing infrastructure goes away, but we build up data services that sit on top of those, that allow phone apps to connect in, that allow tablets to connect in, that allow even web applications and anything else to connect in. So these apps are sort of a big part of our infrastructure as well. In terms of dominant standards, before we get to FHIR, most of the work that supports this particular model is not done with standards at all these days. I mean, that's changing very rapidly, but traditionally, at least, custom APIs were the way that this was almost always done. So people building up custom JSON services, people using SOAP to build up custom services. There is one sort of platform, OpenMHealth, which has seen a fair bit of traction in this world. They're not actually a standard. I probably shouldn't call them that, but they are a specification, and quite a good one, actually. So to sort of summarize in all of this, I mean, there's sort of four big challenges we have in building interoperable systems, or four big areas we need to solve. So data models in general are the first one. Data models, when it comes to sort of supporting especially healthcare apps, but all of the other things I talked about, a bunch of the existing sort of data models we have for representing healthcare data fall either on the too easy, like on the too primitive, or the way too complicated side of the spectrum. PDF being a classic example. I mean, people love sending PDFs of clinical reports, or faxes if that's where you're in. And I mean, those two formats are great for sending human readable content, but of course, computers can't do a whole lot with a fax or with a PDF other than display it on a screen. And on the other side of the spectrum, we've got things like CDA and HL7 version 3, which are great at representing really complicated content, but are themselves extremely complicated, so they tend to get in the way a fair bit. Data transport, naturally we want to move our data from point A to point B. The biggest challenge in the world of data transports for healthcare, I would say, is that there are 1,000 of these standards. Every different type of data you have probably has a different transport, and they all work completely differently. Security has been a pain for healthcare interoperability for a long time. Most of the protocols that are out there and most of the specifications that are out there have treated security as an afterthought. Really, they weren't written with security in mind, and security was only bolted on at the end. And oftentimes the security schemes in these things were system level. They assumed that both systems, in the exchange could be trusted, so they didn't worry too much about who is the user making the request for data. Our final challenge, of course, is the workflow challenge, and I will just summarize that by saying humans are complicated. Any attempt we ever make to standardize healthcare data exchange is always hampered a little bit by the fact that humans will always find some crazy workflow that makes the system not work anymore. That is a fact of life and something we need to deal with endlessly. So to put all of this onto a timeline, we've had a number of these standards that have come around over the years. HL7 version 2 has been around since the 80s. V3 came along in the 90s and still has some deployment out in the world. The clinical document architecture came around in the 2000s, as did XDS. And then finally, around 2011, 2012, HL7 FHIR came along. And that's what I'm going to talk about for the rest of this presentation, is the standard HL7 FHIR. FHIR sort of came along as an attempt to solve the 4 challenges I was talking about before. It basically was attempting to come up with a new approach that used modern technology and modern approaches to exchanging data. It was inspired very heavily by non-healthcare applications. So we spent a lot of time in sort of coming up with the FHIR standard, looking at how other web APIs work, how is data exchanged by things like the Google Maps API and that type of thing, just because there's a number of great APIs out in the world that are outside of healthcare and have done a great job of solving interoperability for other domains. So we tried to be heavily inspired by them. So FHIR itself stands for Fast Healthcare Interoperability Resources. Each of those words has a meaning. I'll focus mostly on the first and the last today. Fast is really important here. We don't mean that the data moves really quickly. We mean that FHIR is supposed to be really fast for you, the developer of software, to use. It's intended to be a very easy thing to learn. It's supposed to be fairly quick to learn, and it's supposed to be very fast to develop with. This is kind of the idea, is it shouldn't require you to take an 8-month course in FHIR just to be able to build your first FHIR application. And we're finding as we test that theory out that it is in fact true. We've heard lots and lots of, we've heard many reports that people have taken FHIR, they've looked at the specification, they've looked at a few samples, and the next day they've started building applications. So we found it's been a fairly fast thing to learn. The other word I'll focus on is resources, and I'm only saying that because I'm going to come back to it in a minute and explain why we say resources and what a resource is. So FHIR, in terms of explaining what it is, I like to describe it as being these 4 things. First off, FHIR is a set of data models. So it's a set of representations of all of the things that we typically do when we typically exchange when we are building healthcare systems and need them to talk to each other. It's a set of API specifications. So basically, it's a way of describing an API that I can use to exchange that data. So I can take all of those data models and use the APIs to move them from point A to point B. Those first 2 things, I would say, are the heart and soul of what FHIR is. And if you look at any other standard that came before it, any of those standards naturally will probably have some take on those first 2 things. But the thing that I think really sets FHIR apart is the third and the fourth thing that also really form the entire entity of what FHIR is. So thing 3 is FHIR is this glorious set of tools and servers. So FHIR is this great sort of set of open source tooling and open endpoints for giving access to data and closed endpoints on particular systems. I'm going to give examples in a little bit of some of all of these things, but FHIR is tons and tons of tooling and servers that are available out on the wide internet. And finally, and perhaps most importantly, FHIR is a community. FHIR has tried really hard to sort of build up a community of like-minded developers around the world. And I'm going to expand on all of these points, so I won't say any more than that here. So let's start by talking a little bit about the data models. FHIR has defined, as of the current release of FHIR, 117 data models for things that you need in order to exchange healthcare data. I've got a whole bunch of examples on the screen. We break them down into various domains. We've got administrative things like patients and their encounters. We've got clinical data, things like medications and observations. We've got various financial data. We've got data around workflows, so scheduling appointments, scheduling tasks for people, filling appointments and booking devices and that type of thing, and a whole bunch of other domains as well. You've got sequences, which are great for people doing genomic work. We've got code systems, value sets, and the various resources that are used for terminology. And there's just an endless set of other domains for various things that you might represent within the world of healthcare. As I said, there are 117 of these data models today. That's in the current release. The next release that will be coming out probably within the next year, probably a little bit less than that even, has a number more. I think the total is up to somewhere around 140 resources in it currently. So who knows by the time it's released how many are in it, but this is a large set of data models that are all sort of comprise the combined data model of FHIR. Each one of these resources is described on the FHIR specification. I have a link to that in a moment, but of course this is all up on the internet for free, so you're welcome to check it out yourself. The most important thing about these data models is they're designed to be really easy for a software developer to interact with. So I've got one example up on the screen that's for the patient resource data model. And the thing that I want to draw your attention to is it is full of these blue bits that you can click on. It works a little bit like a wiki. I mean, it's not a wiki in the sense that you can go in and edit it yourself, but it is much like a wiki in the sense that almost anything in the specification, if you want to learn more about that thing, you can click on that thing and it's a link that'll take you to a place that tells you more about that. So if I want to know what patient identifier is, all I do is I click on the word identifier and I get a great long explanation of how patient identifiers work and probably some examples of them and that type of thing. In terms of the way that we label things in the specification, this is the other point I always like to make about it. Everything is written with software developers in mind. So we try to use terms that are not necessarily the best term for a doctor treating a patient, but are the best term for a software developer who's building software who might not have a full medical education behind them. So we've tried to make things easy to understand for those developers in figuring out how to label things and how to design things within the specification. This is a link. I'm not going to click on it right now, but of course you are welcome to once you get the slides. This is up and available on the internet for free, as is the entire specification. And even if you don't have this link, just Googling FHIR specification will take you straight to that specification, and you can browse it and have a look at the resource list and all of the models and everything else. The second thing that I mentioned that FHIR is an API specification. The best way to describe how FHIR's API works is to sort of contrast it with other APIs. So FHIR, we say, works at the data level and not at the workflow level. So what I mean by that is, of course, the classic contrast, and this is familiar to many people building healthcare software, is HL7 version 2, where we think about messages, and those messages are tied to human workflow steps. So we send a message when a patient is admitted or transferred or discharged, or a new drug has been ordered, or a new pharmacy order has been placed, or a lab result has come back. So all of the steps in the workflow around healthcare are sort of represented by messages in HL7 version 2. FHIR works at the data level, so it doesn't get into workflow at the API level quite so much. We think in FHIR about simple, what we call CRUD operations. So create a resource, update a resource, read a resource, delete a resource, so CRUD. Those are the basic operations in FHIR, and everything comes down to thinking about our healthcare care data in terms of creating it, updating it, and deleting it occasionally. Which is sort of a very different way of thinking about things. It's a much more basic way of sort of building an API, and naturally you can build things like workflow on top of that, but in a lot of cases you don't need to. It turns out that this sort of CRUD model for thinking about things lends itself very well to APIs that scale well and are reusable and are easy to understand. So that has worked out quite well. Everything in the FHIR specification is a verb and a URL. This is the basic principle of REST, which is a fairly popular way of building APIs on the internet today. That I've got a few examples here. So you can create a patient by doing an HTTP post against an endpoint to a server. We can read that patient back by creating an HTTP GET against a patient with its identifier. We can update that same patient by saying put with a patient and its identifier. And there's a whole lot more that I'm not showing here. There are all kinds of things you can do with a FHIR server and a FHIR client, but everything comes down to this basic pattern of an HTTP verb and some sort of URL that you're sort of interacting with. FHIR has this one particular feature that I love to call out because to me it's one of the most interesting things about the entire specification, and certainly as a developer it's the nicest bit of it probably actually, and that's FHIR's search specification. So FHIR allows you to do all kinds of things in terms of search, and that's basically all done by building up URLs. So an HTTP GET, where I say patient and I put a question mark to build my URL and say name equals Agnew, is going to fetch all of the patients on the server who have that particular name. I can search by birth date in the same way by saying birth date equals 2011-01-2. And most importantly, I can combine any of this. And it's as simple as building up a URL that combines the various parameters I want. So I can say name equals Agnew and birth date is 2011-01-02, which is not my birthday, but if it was, that would find me, I'm sure. And I mean, it's kind of just endless. There's all kinds of things in the FHIR search specification that I'm really only scratching the surface of here. But the point I want to sort of get out is that it really is as simple as building up URLs, which anyone who is building software these days will be familiar with. It's a very familiar concept to developers. So people love this idea of searching data just by building a special URL that combines a couple of parameters. I'll talk quickly about tools and servers, mostly to say that there are free implementations of FHIR available in almost any language you might be writing software in today. I've got examples up on the screen of Java. So HappyFHIR is the library I maintain. So the reference implementation of FHIR for Java is a part of the HappyFHIR project. But there are great libraries out there for C#, for JavaScript, for Python, for Ruby, and a whole bunch more. There's a Delphi library. There are libraries for iOS and Android for people doing mobile development. I've heard that there's work going on for even emerging languages, things like Rust and Go and Clojure. There are libraries being built for those platforms as well. So whatever language you're using, there's probably a great library out there that will help you build. There's also a mass of great servers out there. There's all kinds of open servers you can use to fetch data and interact with data. This link, which I won't click on now, takes you to a list of public servers that are out there for testing. And I'm going to talk quickly about the HappyFHIR server, which is the second link on the screen at happy.phir.org. So Happy's server, oops, there we go. Right. I'm going to come back to Happy Server in a moment. I will also say in terms of tools and servers, vendors themselves are getting on board and standing up servers as well. I will mention very quickly Smile CDR, which of course is the repository that I am a part of. We're built on top of Happy FHIR, and we've got a URL there. So we are selling a full-blown repository that can be used as a backend for all kinds of healthcare systems. There are a whole bunch more out there. Vonk and 8box are sending purpose-built FHIR repositories. A number of the big EHR vendors are putting FHIR APIs on top of their systems. Epic, Cerner, and Allscripts are the first three big ones, but there's a number of other HIS vendors adding FHIR interfaces as well. And the integration platforms that are out there are starting to add FHIR as well. So the interface engines certainly have it. Your Mirth, your CorePoint Health, all of them, they've certainly got FHIR support either in progress or in the product. All kinds of other bits of software have that as well. As I mentioned, we maintain a public sandbox, the Happy FHIR test server. I've got a screenshot of it on this slide. And as I mentioned, it's at happy.phir.org. This is an open sandbox. So if you want to try interacting with a FHIR server yourself, this server is up on the internet. It's free, it's open. You're welcome to store data in it. Of course, not production data, it's for testing, but you're welcome to store your testing data in it. The really fun thing about a public FHIR test server is that people are testing their own software against this system constantly. There is always someone at any time of the day testing their system against this server. So you've got lots of examples of what type of data are other people using, which can be really useful as you build your own systems as well. Happy also has a version of this software that you can run on your own computer. So if you want a little private version of the Happy FHIR server that you run yourself, we've got the Happy FHIR CLI, which is our command line version of the Happy FHIR server. Available as well. I mentioned FHIR is a community as well, and I think this is kind of an important thing to highlight. Much of the work around HL7 FHIR happens, or at least much of the community building work happens at these events called Connectathons. And I've got a photo of one of the US Connectathons on the screen here. Connectathons are these great big events where tons of software developers get together and try parts of the specification out, learn the specification together, try and make their systems talk to each other, make human connections and meet the other people doing interoperability. So we've been doing these events for a number of years now, and every single one of them is a little bit bigger than the previous one. Almost more exciting to me is that we're starting to see these events happen around the world as well. We run one in Canada every year. There are a number of them that happen in Europe every year. We ran one in Vietnam a few months ago as well, which was extremely successful. We had a number of people come there and learn FHIR basically within the day, and by the end of the day, they had connected their systems to a FHIR server. So this entire notion of running these Connectathon events has been a big part of the community efforts of FHIR. FHIR as a community is rapidly growing around the world. I love showing this slide. This is actually an analytics slide from our website, from the Happy FHIR website, showing developer access to our documentation, which I think is a good sort of indication of how many people are using FHIR and where they're using it. A few patterns sort of I think are interesting to look at on this slide. First off, of course, North America and Europe are heavily represented, which makes sense. FHIR does come, out of a US-based standards organization with a lot of European participation. But interestingly to me as well, there is obviously from this, you see a global footprint. Our biggest set of users has been India basically since the start. And I think a lot of that comes from there being a very large tech sector in India, of course. So there are a number of developers building systems in FHIR there. We're also seeing a very, very much a growing presence in the Asia region. So, I mean, as you can see on the slide, we've got, a large amount of use in China, a large amount in Japan. We're starting to see lots in Southeast Asia as well, or at least we're starting to see some in Southeast Asia as well. So lots and lots of work around the world on FHIR, which is exciting. And I'm hoping over time we will see more and more in the rest of the parts of the world where we don't see dots today. I'll talk quickly about security to mention Smart on FHIR. And sort of to introduce that topic, I will say that FHIR, of course, is a standard for modeling data and exchanging that data. But FHIR does not specify that you have to do security in any particular way. It doesn't get into what's the right way to secure the application. But it does, of course, say that you need to have security. Of course, if we're dealing with personal health information, with health data, we need some sort of security on it. And Smart on FHIR is one popular option for this that we're in the process of actually adopting into the FHIR specification as a formal part of that specification now. Smart on FHIR is this nice framework that you can use to sort of connect apps into EHRs. That's not the only use case for Smart, but it's a great place to start in terms of describing what it is. So what we mean by that is we assume, let's say in a hospital, that we've got an EMR system of some sort, and that EMR system is collecting all sorts of clinical data. If we want to connect an app, a special purpose-built app that does something really well into that EHR to collect data, then Smart allows us to securely make that exchange happen. Smart sort of is a specification that bundles up three other things together. First, it uses OpenID Connect with a set of these healthcare scopes, they're called. We do that for authorization. OpenID Connect is the technology that is used, for example, to allow you to log on to something using your Google account or using your Facebook or your Twitter account. That sort of delegated authorization where you're using a third-party authorization server to log into something. That's OpenID Connect fundamentally. And Smart on FHIR has taken that protocol and sort of tailored it specifically to healthcare. Smart on FHIR, of course, recommends or specifies that we use FHIR, the standard for exchanging data. And finally, Smart on FHIR specifies a set of launch URLs, which are basically these really fancy but really simple little URLs that allow us to launch a web application from inside an EHR with things like the currently selected patient staying in context, information about the current working user still in context. So basically, it allows some context sharing between an EHR and an app. So those three things combined, that's what Smart on FHIR really is. I always put this slide up just because I think it really drives home how we do the authorization part of Smart on FHIR. I think lots of people, and hopefully lots of people on the call today, have seen this screen before. It's the classic, I'm authorizing something with Facebook. Basically, I'm allowing an app to do something like post on my Facebook wall on my behalf or something like that. That is the OpenID Connect / OAuth 2 protocol in action. And if you sort of imagine that exact same workflow happening for healthcare, but maybe instead of post on my wall, we're now requesting access to look up lab results or write back to the chart or something like that. Those are the scopes that we sort of allow, and it's the exact same workflow actually as Facebook that Smart on FHIR sort of specifies. Finally, in terms of describing Smart on FHIR, I will mention that they've got this lovely gallery of smart apps, and these are all apps that you can kind of browse through and look at. Some are free, some are open source, some are vendor products that are for sale. So there's a wide range of types of applications. But I mean, the thing that they all have in common is they're all sort of fairly focused, purpose-built apps that do something well. And there's tons of them up there. So that the website for that is at apps.smarthealthit.org. Well worth checking out just to have a look at what types of apps people are building today. And of course, all of these are powered by the Smart on FHIR specifications that allow them to connect into the rest of the EHR. So that is all I have to say today, and it looks like I'm exactly on time for where I wanted to be. That's awesome. I will mention I love talking to people, so I will put a couple of links up here. If you're interested in discussing FHIR, the project, the best place to do that is we have a Google group up. This is the link here. We are there's a great community up on the FHIR sort of community group. Whatever your question is, someone will get it in and answer it for sure. Also, I've got an email. I'm happy to hear emails. I'm happy to talk on Twitter. And the one link I forgot to put on here that I meant to put up here is there is an open chat server for FHIR called Zulip, and it's at the URL chat.phir.org. I am going to add it to this slide before I circulate these slides. So if you didn't catch chat.phir.org, come back and look at this last slide on the presentation when I circulate it, and you will see that link on there. Chat.phir.org is an amazing resource for FHIR developers in that it's a real-time chat platform on the web that is populated with people from around the world doing FHIR implementations. So if you have a question about anything FHIR, there is probably someone on there that would love to answer your questions. It is a really, really friendly, really welcoming community, very open, very supportive. So certainly it's one of the most exciting things about FHIR, actually. So I would certainly encourage people to go to that. That is all I have to say. So thank you for your time. Thank you for listening.
Thank you for that lecture, Professor James. We are now open for questions, so if you have questions, please type them in the questions box. All right, so the first question is from Engineer Derek Ritz. It reads, this diagram, the application model, doesn't illustrate the interoperability piece. Might the apps be connected to the repository rather than the EMR?
Yeah, there's a great question and something I should have probably pointed out. So, I mean, Smart on FHIR and a lot of the initial work around building interoperability for apps has focused heavily on the idea of an EMR, an HIS, or something like that being connected directly to an app. And the reason that we sort of start there is because this is the dominant way this is done in the United States. This is, the reason for that is basically that in the United States, the EMR vendors have a lot of power, and they do tend to be the sort of center where healthcare data gets aggregated. This is not the case in much of the world, actually. Here in Canada, as an example, we have gone with this model of building up repositories that exist between organizations. And certainly the way we're thinking here in Canada is having apps connect directly to those repositories or through gateways and things like that. There's a bunch of other parts of the world. I mean, this is basically similar thinking is happening in places like Denmark, the Netherlands, Australia. So there's lots of talk in other parts of the world around connecting things as well. And certainly, I mean, just to talk about my own product a little bit, that's exactly the model that we're talking about with Smile CDR, is standing up repositories to power apps and then having data populate into those repositories.
All right, thank you, Professor James. Our next question is also from Engineer Derek. It reads, the cardinality of a required element would be 1. Would, would it not? Sorry to be picky on that point, but it looks optional to have an ID, for example, for patients.
Okay. So there's a fun question. So, I mean, I guess the first thing I will say there, hopefully I'm grasping that question correctly. The FHIR specification by default makes very few things required. It goes with an approach that almost everything in the specification is optional, with the idea that profiles will be built up for specific uses within specific jurisdictions that constrain the specification down, that make things required where they need to be required. ID is specifically kind of a weird one. any resource that has been saved in a server is required to have an ID. ID is only listed as not required in the specification because if you are sending a resource to a server for the first time, you are not required to send an ID, because in that case, the server is going to receive it, it's going to assign an ID, and then it's going to come back and tell you what that ID is. In every other case, you will have an ID. Basically, the resource is always required to have an ID because the server has given it, has assigned that ID. What else is worth saying there? There are a number of projects out there. I didn't talk at all about the Argonaut project, which is really kind of an exciting project happening in the States and is starting to sort of see some reuse around the world. Argonaut is building up a set of constraints on FHIR specifications for basically for powering apps. They have built up a number of sort of constraints down that say that all resources will have identifier. You know, my patient is always required to have a birth date and a sex and that type of thing, and a name. So they've basically constrained the profile down to a reasonable set for apps. And what we're now starting to see is that other countries are looking at the Argonaut project and their profiles and looking at how can we customize these a little bit more for our country and then reuse them here. So this is starting to be a popular initiative as well. Hopefully I got it. Yeah, I got at your question with that.
All right, thank you, Professor James. So for those with questions, you can still type your questions in the questions box. And if you cannot find it, we also have the chat box. Thank you.
Hello?
Yes, hello, Dr. Bunsai.
Yes, thank you, James. This is Bunchai. I'm the chair of the Asian eHealth Information Network, and it's really informative and happy to have you at the webinar of our AeHIN webinar. Actually, I'm now in Ottawa for a conference. The sound is very clear. And I hope that someday that we can have you in another next webinar and also our meeting. Thank you. Thank you very
Absolutely.
much.
Thank you.
All right, thank you, Dr. Bunchai. Sir, we also have another question from Mr. Ryan Crichton. It reads, could you say a little more about what OAuth scopes are specified with SMART or FHIR?
Sure, I can definitely talk about this. So we're getting, this is great. This is kind of a little bit more advanced question around OAuth 2. So for anyone who's wondering, I mean, the question is what OAuth 2 scopes are specified in SMART. I'll start by explaining quickly what an OAuth scope is, because I think that's kind of important. The idea is a scope is basically a permission that an app can request, you know, on behalf of it, to do on behalf of a user. So if we were talking about Facebook before, an app might request permission, you know, to post on my wall on Facebook on my behalf, or it might request permission to manage my messages, or just to log in, or to learn about my email address. There's all kinds of things that an app can request permission to do when I log in through Facebook. And each one of those things is actually a scope. So a scope, very simply, is just a fairly fine-grained permission that an app is requesting. And typically an app is going to request a bunch of these scopes for all of the things that it needs to do. You can think about it a little bit like when you install an app on your phone and you give it permissions to use the camera. Like that's not an OAuth scope, but it's the same kind of concept. In Smart on FHIR, we use these OAuth scopes, or we create a set of these OAuth scopes that are specific to healthcare purposes. And they really come down to the way FHIR thinks about data. So OAuth scopes in FHIR, or in Smart on FHIR, they basically look like things like, I am requesting permission to read a specific patient's data. So I can request, and there's a scope, you know, the exact syntax is like patient.star/what/ it's patient.star/read. Which, I mean, the exact details of the scope is all written down, so it doesn't matter. But what we're specifically requesting here is read-only access to all data about a specific patient. There are also scopes for reading one particular record, or reading a specific resource type only, or writing a different resource type. So I could sort of very easily within a FHIR application, for example, request access to read a patient's chart and write back observations, but nothing else. Or maybe I could request permission to schedule appointments and read about patients, but not delete appointments and not look at observations. So it allows fairly fine-grained access to healthcare data, all sort of scoped around the way that FHIR models data. So that's kind of the general idea with OAuth Scopes.
Hello, James. Can you hear me?
Yes, I can.
So this is Raymond. I'm in Hanoi right now. So I just wanted to, I just want to give you props for all of the help and support and the present slide deck and the report actually that you were able to provide us for this interoperability workshop that we'll be starting tomorrow. I wanted to ask you, and maybe you could also share how HL7 FHIR could actually help in terms of developing guidelines for national EHR implementation. How it could actually be it could be a preferred method in terms of developing national profiles for implementation.
Sure, absolutely. So I guess, I mean, it's a fun concept. I mean, FHIR, if you look online at what people are doing with FHIR, I mean, all of the excitement that you really see being talked about publicly is around apps, which is kind of the exact opposite of a national EHR, actually. Like, we're talking about these really small purpose-built systems that are talking to an EHR or something, and doing one thing quite well, which is, I mean, of course, is a great thing and is very exciting, but is kind of the opposite of a big national EHR system. And this is not to say that FHIR isn't a great solution for national EHRs, and we're starting to see people use them in that, use the specification in that way as well. I mean, ultimately, I think that was kind of my purpose with starting with those descriptions of EHR, is just to talk about sort of the models we have. The place where I think FHIR really finds its niche when we're building great big national EHRs is in simplicity of sort of implementing specifications. I think back always to my work on a system here in Ontario, Canada, called OLIS. I did a lot of work on that. OLIS is a lab database that collects every lab test performed for every patient within our province, which is about 6 million people. So, you know, it's not the biggest database ever, but it has a fairly wide scope. We developed for it a really, I mean, I think it was quite nice HL7 version 2 specification for populating it and querying it and all of that stuff. And the thing that we found is that the hard part was not building the standard or building the database or building viewers on top of it or anything like that. Those were all challenges, but ultimately what was hard was gathering data from, you know, 200 different hospitals and 10 different private lab providers and all of the different people that we had to gather data from. Every one of them had a different EHR, and every one of them had to build some sort of interface in to transmit data to us. And naturally, I mean, that is not an easy thing. I mean, you have to be really good at HL7 version 2 to be able to build a complicated interface for standardizing lab data and getting it in. FHIR brings down that barrier, I think. It does not solve this problem. I mean, it certainly doesn't make it so it's trivial to develop an interface, but it absolutely provides a really good way of describing what is your data model, what is your API specification, what are the rules around those things. So it provides just a really nice way of sort of standardizing the process of gathering data from a wide variety of sources. That to me is, I mean, almost, I think it doesn't have all the buzz yet, but I think this is going to be where FHIR truly shines, actually, is in simplifying great big national systems. Also, best of luck with the interoperability workshop. I hope things go well in Hanoi this week.
Thank you, buddy. We missed you. We hope you will be able to join us during the enterprise architecture workshop in a few weeks.
Cool.
All right, I think there are no more questions. Professor James? We would like to thank everyone who attended this webinar, especially Professor James for sharing your time and expertise with us. We would also like to invite everyone to join next week's webinar. Our speaker will be Dr. Raymond Sarmiento on March 6, 8 p.m. Manila time.
Yes, I'll be discussing real-world implementations of FHIR. I'll be touching also on the potential of FHIR to be used as a terminology service.
Okay, thank you, everybody.
Bye, thank you.
Bye.
Thank you again, James. Thank you.